After reviewing the topics taught in this course, we decided to do a video explaining short-circuiting to everyone.
So what is short-circuiting? Short-circuiting occurs when given a Boolean expression, the outcome of the operation being performed can be determined by the value of the first sub-expression without even having to consider the value of the second sub-expression. When this happens, the compiler is able or allowed to essentially skip evaluating the second sub-expression and produce the proper Boolean result. Occurrences of short-circuiting appear in Boolean expressions that use the like pipe or ampersand operators that represent logical or and logical and respectively. So why would you ever use it? In general, we say that it is advantageous to use short-circuiting in programming and or evaluation because it can be helpful in mitigating or avoiding potentially computationally expensive tasks. As a simple example to demonstrate what we mean is that if you have a very long line of code, such as like this really long Boolean statement here that ORs a bunch of true false statements. It may take the compiler a really long time to look at every single Boolean statement and operator. But we know that when evaluating a Boolean expression with a logical OR operator, if any part of the expression is true, then the whole expression evaluates to true. By looking at this particular example, if we can implement short circuiting, then the program knows that by the very first Boolean expression is true, and it can immediately evaluate that this entire expression is true without even having to consider the rest. So how can it be tricky? It can be tricky and confusing in that short circuiting only works if things are implemented in a certain way. We call this certain way the evaluation order, in which sub-expressions within an overall expression must be evaluated in a particular order to be properly functional. The evaluation order typically defines the order in which sub-expressions should be evaluated to avoid errors or bugs in the code, as some sub-expressions may be dependent on the value of a previously evaluated sub-expression. However, in our case, for short circuiting, we can take advantage of this and use evaluation order to determine whether or not an expression is capable of short circuiting.
Here's an example. So up top we have a function is odd number, and it'll go down into the if statement and it'll say num mod 0 equals 0, which is false, else true. Next we have def foo. This will go into the if statement if is odd number, and it'll do an and with the print, and it will short circuit on the is odd number because the number is 24, so it will not do the print statement. And then this is a set of inference rules that allows us to for short circuiting by explicitly stating the evaluation order of the code must follow when trying to implement a function that will calculate the division of the number n1 divided by another number n2. In math, we know that we cannot divide by the number 0. It's the most important rule to keep in mind when dividing numbers. If our second number n2 is 0, which is evaluating with search divide 1, we can tell the code to short circuit without evaluating our expression for search divide 2 because there's no point in evaluating that sub-expression if we already know the expression is already undefined as we would be dividing by 0.
With that, that concludes our presentation on short circuiting. Thank you.